y is equal to tangent x. This is the one you were graphing at the beginning of class. Let's see if you got it. Okay, now you did not have to put your asymptotes all the way over there. As long as your asymptotes are marked at negative pi over 2 and positive pi over 2, you're good, okay? So do you have your left asymptote at negative pi over 2? Do you have your right asymptote at positive pi over 2? It's okay if you didn't go over 2 spaces. That's fine, you don't have to do that, okay? And then you need to have 3 points. So in addition to the point at 0, 0, you have a point at pi over 4, 1, and a point at pi over 4, negative 1. Again, if you didn't use 2 spaces, that's okay. For your domain, we went over this on day 3. It's everything except for the asymptotes. So you have an asymptote already at pi over 2. Let's see. Okay, so you have an asymptote already at pi over 2, and then the next asymptote would be a distance of pi away from that, which would be at 3 pi over 2. Every time you add pi, you get another asymptote. The range is from the bottom, negative infinity, all the way to the top, positive infinity. The period is the length of the graph. A lot of people think the period is where you end pi over 2. It's not where you end, it's the length of the graph. So if you end a period at pi over 2 and you started it at negative pi over 2, you could subtract those to find the length. Minus negative is plus positive. So this is a half pi plus a half pi, which makes a whole pi. And then the midpoint of this one is 0, 0. Of course, there'll be another midpoint at pi 0 and then at 2 pi 0. Any questions on this before we go on to transformations? Okay. So next one. What does the plus pi over 2 do? Left. And how about the minus 3? Down. So we're going to go left, pi over 2, and we're going to go down 3. Some people like to make a midline. It doesn't work exactly the same as the midline. Oh, I did that wrong. It doesn't work exactly the same as the midline for sine and cosine. There we go. But you can still do a midline if you want. Just make sure you put it the right number. So this would be at minus 3. Okay. All right. I'm going to, because I want to have space to move around, I'm going to just count by one box each time. So I'm going to put negative pi over 2 here. Negative pi here. Negative 3 pi over 2. 0 pi over 2. When you transform tangent, it's very important that you transform the midpoint first. So the midpoint that was at 0, 0, that's going to go left to negative pi over 2. And then it's going to go down, sorry, so we're going to actually end up here. That was negative pi over 2. So this is my midpoint right here. Then my period is pi, right? So the whole length of the graph is going to be a length of pi. So I need half of that graph on the left and half of that graph on the right. So if my midpoint's at negative pi over 2, what's half of pi to the left? Where will I be if I go half of pi to the left? I'm going to be right here. You see that? So I need the whole length of the graph to be pi, so I'm going to go half pi to the left and have an asymptote right here. And I'm going to go half pi to the right and have an asymptote right here. And now the whole length of my graph is pi. So you start by moving your midpoint, and then you build the graph half of the period to the left and half of the period to the right. Now tangent's increasing, so you're going to have a point that is, let's see, this is negative pi over 4 here. So negative pi over 4, 1. And then negative 3 pi over 4, you're going to have one at, I'm sorry, that's not 1. That would be negative 2. But it's 1 above the midline. Okay, so I'm going to write down the words for what I was telling you there. To transform tangent, you need to shift the midpoint first. Okay, my domain is all real numbers. X does not equal. And what's one of the asymptotes? Negative pi is 1, positive pi is 1. What's another one here in the middle? 0. If 0 is an asymptote, that's a nice one to use because when I do 0 plus, then it would simplify, right? What's the distance between my asymptotes? It's pi. So it would be 0 plus pi k. But 0 plus I don't need. So basically, x does not equal pi k. Because 0 plus pi k is the same thing as pi k. For tangent and cotangent, my range is always going to be negative infinity to infinity. And the period we know for tangent and cotangent is pi. What's the coordinate of my midpoint here? Negative pi over 2, comma, negative 3. Good. Okay. What questions do you have before we go on to the next one? Okay, I see a few people still writing, so let's give them a minute, and then we'll go to the next one. But feel free to look ahead and think ahead. Okay, for this one, what does the 3 change? Vertical stretch. I love that because I wanted to say amplitude, but you guys help me. It's vertical stretch. And then the 1/2 changes the what? Changes the period. All right, so my period, instead of being 2 pi over b, it's pi over b. Because pi is the regular period for tangent. So you're going to do pi over 1/2, which is pi times 2 over 1, which is what? 2 pi. Okay, what did I just tell you is the first thing we have to transform? The midpoint. Very good. So my midpoint is stretched by 3, but what's 0 times 3? 0. So my midpoint's going to stay at 0. Let me label my axes before I move on. Pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2. Okay, and 1, 2, 3. All right, so my whole period is 2 pi, which means that the whole length of the graph has to be 2 pi. So how much of that is going to be on the left side? Yeah, half of it, which is pi. So we're going to go pi to the left, which puts us here, and pi to the right, which puts us here. All right, we haven't seen the vertical stretch yet, so we need to see that vertical stretch in our next point. I'm going to go over halfway between the midpoint and the asymptote, and I'm going to go up how many? 3. That's where my stretch shows up. And then go halfway between the midpoint and the asymptote, and I'm going to go down 3. All right, now make sure that you're trying to graph the curve here. It's especially hard for me to do this on this mouse pad, but it's going closer to the asymptote. And it's going closer to the asymptote. Okay, if you're ahead, then you should be working on domain, range, period, and midpoint. We already calculated the period, and my midpoint didn't change. Who wants to take a stab at the domain? Yeah, go ahead. Thank you. Okay, so all real numbers, x is not, so you noticed that there was one at pi, right? Okay, so let's start with that one. And then, let's see, plus pi k? What do you guys think? Is it a distance of 2 pi between? Yeah, okay, good. So that was a good start that we had the pi here, and then let's put the distance of 2 pi in between. Nice teamwork, guys. So there's 1 at pi and then a distance of 2 pi in between, and our range did not change, did it? Okay. All right, any questions? Let's give everybody a minute to get that one and we'll do the next one. All right, I'm going to let you try that one before I get started. So I know you know what the numbers are going to do, but you have to believe me when I say you have to do the midpoint first, okay? So look at the last problem. And the very first thing you have to do is move your midpoint, and then you can work on the rest of it. Compare notes with each other, work together, but take a second and get that one done. So what does the minus pi over 4 do? Which way? Right. To the right. And what does the 2 do? It made your period into what? Kieran. Kieran. The 2 changes your period to what? So remember your formula is pi over b. And 2 is your b value. Pi over 2, very good. So pi over 2 is the whole length of your graph. So if I label this negative pi over 2, and this is negative pi, 1, 2, okay. So I'm going to go, right pi over 2, pi over 4. So I'm going to go right pi over 4, that puts me right here. Is that what you guys got for your midpoint? Okay, because you have to start with the midpoint. And then the whole length of the graph, the whole entire period, is pi over 2. So the whole thing fits in just that small space. You need to go half of the period to the left and half of the period to the right. So what's that actual distance, half of pi over 2? Pi over 4, yeah. So you're just going pi over 4 to the left.
Why is it only in that small space instead of, because the period is pi over 2, why is it
Yes.
pi over 2 all the way on the right?
Oh, you mean why did I not label my axes differently?
Yeah.
Okay, so the labeling of the axes is a personal choice as long as you're going an equal amount each time. So if you choose 4 boxes to be pi over 2, that's fine. Or you could choose 2 boxes to be pi over 2. By labeling consistently here, I'm showing you the compression. So you can see the compression. I understand we did it differently for sine and cosine because sine and cosine had 5 points, so it was a little bit harder to keep track of. You don't have to erase it if you labeled it differently, as long as you have an asymptote at x equals 0 and an asymptote at x equals pi over 2, you're good. Okay, and then you have 2 more points, so halfway between the midpoint and the asymptote, you're going to have another point at pi over 4, negative 1. No, this is pi over 4. This is pi over 8, right? And 3 pi over 8, positive 1. Okay, remember that all of these graphs repeat forever. So even though we're just doing one period of the graph, we could keep marking the axes. And we could make more graphs in each one. Okay, so our range has not been changing, negative infinity to infinity, and we calculated our period to be pi over 2. And I see my midpoint here is at pi over 4, 0. But the big mystery is the domain. So if you haven't done the domain yet, take a minute to think about it. Compare with a neighbor. And if you can help us figure this out as a team, then I'll ask you to volunteer in just a minute. All right, Casey, did you get it? All right, Casey's going to give it a stab, okay? Let's see if you guys agree or disagree, or if you want to use it to build on. Go ahead. Okay, did you hear that? She said all real numbers x does not equal pi over 2k. If you think that that's exactly what you wrote down, raise your hand. And then add your hand if it's not exactly what you wrote down, but you think it's also right. All right, so in that case, it sounds like Casey's using 0 as the first asymptote. So it'd be 0 plus, and then the distance is pi over 2. So 0 plus pi over 2k, which does simplify to pi over 2k. So that sounds very good. All real numbers, x does not equal pi over 2k. Did anybody have something different that you think is also right? Remember, you can start at any asymptote. So I could have started at pi over 2. I could do pi over 2 plus pi over 2k. Or I could do pi plus pi over 2k. Remember, k is an integer? You guys haven't been reminding me. We have to write k as an integer every time we write k. I know. You know, there's a fun way to write it, though. You can write k as an element of z. All right, k is an element of z because z stands for the set of all real numbers. Okay? You know how the fancy R means all real numbers? I'm sorry, Z is all real integers. So Z is the integers, R is the real numbers. Okay, may I move on? Next page is cotangent. Some of you guys already have the cotangent graph up. If you don't have it up, you can get it from your notes. Or you can get it from right here. All right, for cotangent, you're going to transform the left asymptote first because the left asymptote is on the 0. Here we go. Cotangent 1/2 x. Amen. 1/2 changes what? Yes. Yeah, you're showing me the right thing. That's the period. Good. All right, so 1/2 changes the period. So now my period is going to be pi divided by 1/2, which is pi times 2 over 1, which is 2 pi. All right, so remember I said you're going to transform the left asymptote first. I'm not shifting left or right, so the left asymptote is actually going to stay put. Start with left asymptote. And then here's pi over 2, pi, 3 pi over 2, 2 pi. Okay, so this is my left asymptote. The entire period is 2 pi from the start to the end. So where do I put my right asymptote? At 2 pi, because my period's 2 pi. Yep. Okay, so I started with my left asymptote at 0. That comes from the parent function because there is no shift left or right. Then, because my period is 2 pi, I had to make the right asymptote at 2 pi so that the distance between the asymptotes is 2 pi.
And you got that from finding the period.
Yeah. So when I found the period, I realized how long my graph had to be. Then you find the midpoint. So notice that's different from tangent. For tangent, you started with the midpoint. Okay? So next we're going to find the midpoint halfway between the asymptotes. Where is it? Yeah, the midpoint's right here. Now cotangent, is cotangent increasing or decreasing? Cotangent's decreasing, so my up point will be on the left and my down point will be on the right. And then do your best to draw the curves going towards the asymptotes. All right, my range has not changed. I already calculated the period, and I can see the midpoint right here. Did anybody already figure out the domain? I have 1 at 0, and what's the distance between the asymptotes? 2 pi. So it's going to be all real numbers. That's right. Yes?
How do you know, like, what points to go through when you're graphing?
Good question. Let me finish the domain up, and then I'll answer that one. Okay. So Greg gave us all real numbers. X does not equal 2 pi k. All the multiples of 2 pi are going to be asymptotes. EJ asked a good question. How do you know where these points are going to be? So to find the x-coordinate of the point, it's halfway between the midpoint and the asymptote. So halfway between pi and 0. And then to find the y-coordinate, it depends on the stretch. So if there's a stretch, it would go up like 2 or 3. But since there's no stretch, it just goes up 1. And the same down here. Okay. Other questions on this graph? Raise your hand if you would like another minute to look at it before we move on. Okay. All right, we're going to wait 1 minute. Okay, guys, next one. What does the negative do? Reflects it. What does the plus pi over 2 do? Yes, so write those words down. What did I say I want you to move first for cotangent? The left asymptote. So take your left asymptote from 0 and move it left pi over 2. Okay. Did the period change? No, so the period's still pi. So if the whole distance of my graph is pi, where will it end? I heard 1 vote for pi over 2. I heard a nod. Okay. If the whole distance of the graph is pi and you start at negative pi over 2, then you're going to end at positive pi over 2. It's right. So that's your other asymptote. Where's the midpoint going to be? At 0, 0. Very good. Halfway between the asymptotes. Now, cotangent normally is decreasing, but what changed?
It's reflecting, so it's increasing.
Yeah, the reflection's going to make it increase. So at pi over 4 and negative pi over 4, I'll have my other 2 points. All right, so when we reflect a cotangent and we shift it pi over 2, what do we get? What's that graph? Tell your neighbor what that graph is. We've seen that graph before. Do you guys remember seeing this graph? Am I just making this up? Didn't we see it right here? Okay, so this is the same as your tangent graph. Yep, very good. One more. Okay. Next one's for you. Oh, we didn't finish this one. Domain and range. Okay. All right, finish that one up, and then you guys try the next one. For the -3, did you move your midline down to -3? So that's the middle of your graph, right? And then the 2 is going to be a vertical stretch. So that doesn't change your first asymptote. So your first asymptote is still here, right? And where's your second asymptote? Where's the next asymptote, guys? At pi? Next asymptote's at pi. And your midpoint shifted down 3. All right, and then cotangent is decreasing, so on the left we should have our up point, but our up point is not up 1, it's up how many? 2, thank you. 2 up. And then our down point should be 2 down. Okay. All right, if you got that right, give yourself a pat on the back. If you didn't get it right, but you still got something and you learned something from trying this problem on your own, give yourself a pat on the back. Okay? Very good. And let's do the rest. Domain, range, period, midpoint. Range has not changed, and our period didn't change. The new midpoint is what? Pi over 2. Negative 3, good. And our domain is all real numbers. X does not equal what? Pi k. Beautiful. All right, so tangent and cotangent has been a lot of work, but we still need to talk more about sine and cosine graphs because we need to be able to write the equation for a graph when we look at it, and that's going to be on the next page. Okay? So did anybody turn the page and look at that already? Yeah? Anybody try it yet? I'm gonna try the third problem with you, and after I do the third problem, I feel like you guys can do all the rest. Okay? So go to problem number 3. Here we go, number 3. Did you guys find the right problem? We're all looking at problem number 3? All right. Number 3. The equation is the last thing you're going to write, so don't do that first. Sine or cosine? Okay, guess what? Anybody is right, because it could be sine or cosine. If I started it right here, if I started it right there, would it be sine or cosine? Cosine. If I started it right here, what would it be? Sine. Right. What if I started it down here? Negative cosine. Very good. Yeah, this actually would be a negative sign. This would be a negative cosine. All right, so it depends on where you start. Now, for the purposes of doing the same problem together, we're going to choose the same thing. So I heard most of you voting for cosine, yes? Do you want to start here and have a positive cosine? Okay. So you have to choose your start point, and then you can decide if it's sine or cosine. So we're going to say cosine. You need to find your midline, and your midline is halfway between the maximum and the minimum. So where's my midline going to be? Right here? What number is that? 1. So my midline is at positive 1. My phase shift, my start point is not on the y-axis, so which way did I go? I went left, and look at your paper, because mine is a little bit messed up. How much did I go left by? Left pi over 4. If this is my start point, is there a reflection in the graph? No. If I started down here, there would be a reflection, but for my start point, there's not. And the amplitude is the distance from the midline to the top. So what's my amplitude? 1. Right. From 1 to 2 is a distance of 1. No, it's okay. It's tricky to look at. So then the period is the length before it starts repeating. So I'm starting here. And then when I get here, it starts repeating. So how long is that? From negative pi over 4 to 7 pi over 4. I'm going to subtract them. 7 pi over 4 minus negative pi over 4. Right. It's 8 pi over 4, which is what? 2 pi. So my period is 2 pi. Oh, that's too many lines. 2 pi. And then my b is 2 pi over 2 pi, which is what? And whenever you divide something by itself, you get 1. Okay. So for the equation, we're going to use this format. We're going to use y is equal to a cosine b x plus c plus d. And let's see. Y is equal to, my a value was 1. Cosine. What's that? No, you don't have to write the 1. And then my b value is 1. And again, you don't have to write the 1. All right, if I'm going left pi over 4, is it plus pi over 4 or minus? Plus pi over 4. And my midline is 1, so plus 1. So some of you guys pointed out that you could make this a little bit shorter by writing y is equal to cosine x plus pi over 4 plus 1. Okay? All right, so for problems 1 and 2, look at the graph and choose your start point, and that will help you decide if you want to do sine or cosine. And then figure out your answers down here before you figure out your equation. Then check with your neighbors, see if they got the same equation. It's possible to get a different equation if you choose a different start point. More than one equation can describe the same graph. So you could have 5 different correct answers in your group. All right, so I'm going to pause and I'm going to let you guys work on that. Yeah. So, did you guys pick sine or cosine? You guys picked sine, okay. And where did you put your midline? Did you all pick -1 for the midline? Okay. All right, this time somebody other than Jack. Phase shift. None, if you pick your start point right here, right? Okay, somebody new, reflection? No reflection if you're starting right here. All right, Annabelle, the amplitude? Amplitude 1, 2, 3, good. And length of the period? So I think that's your B value, right? Yeah. Okay, so you're just jumping ahead. So if your period is pi, right? Then your B value is 2. Okay, so who's going to read us the whole equation from your group? Be anyone. Okay, go ahead.
So y equals 3 sine 3x minus 1.
3x. Wait, are you sure about the 3 there?
Oh, never mind.
3 sine
2.
2x. That's your B. Good. All right, good teamwork, guys. Raise your hand if you got the exact same equation. I thought you guys didn't do one.
I've been working on it.
Okay. All right. A few people got the exact same equation. Does anybody think that they got a different equation that's also right? Remember, there's more than one right equation here. Who has a question on their work? Okay. Go on to number 2 then. All right, for number 2, you guys said you should pick cosine?
Yeah.
Okay. Where was your start point then? At 0?
3.
At 3 pi? Right here?
Yeah. Oh no. Oh no. Yeah. 0. Sorry.
0. Okay. All right. So Johnny, where's your midline for number 2?
3.
At 3, right here. Reflection. Very good. Thank you. All right, Lena, what do you have? Yes. Good. Christina, is there a phase shift? Is there a phase shift? No phase shift if we start there. And what did you guys get for your period?
0 to 4 pi.
Okay, so from 0 to 4 pi is a length of 4 pi, so we did 2 pi over 4 pi, and we got what for B?
2.
Well, the pi's are going to cancel.
1/2.
1/2. All right, so who in your group is going to read us the whole equation? What?
All right.
No.
Oh yeah.
Y equals.
-2 cosine. 1/2 x plus 3. Yeah, there.
Okay. All right, raise your hand if you have exactly the same thing as them. Raise your hand if you have exactly the same, Colleen? Yeah. Raise your hand if you have something different that you think is also right. Anybody have a different equation? I want to hear it because I know there's other equations out there. What if I started right here? If I started right here, would it be a sine or a cosine? A sine. If it's a sine right here, I'd still have an amplitude of 2, but it wouldn't be flipped. And I would still have a midline of 3. And I would still have a period of 4 pi. So a lot of things would be the same. I would just have no flip, and I would have a phase shift added in. Okay? So remember, more than one way to do these. All right, so we did 1 and 2. Did anybody start working on the bottom part yet? No? All right, take a minute to work on those questions on the bottom. Okay, go ahead.
Y equals 4 cosine parentheses x plus pi over 2 parentheses plus 5. I need minus 5.
All right, is that okay? Yeah? Any questions?
No.
Okay. Next one, raise your hand if you're willing to volunteer your answer.
For which one?
Kieran.
Y equals negative 1/2 cosine of parentheses x close parentheses plus 4.
All right, what do you think of that one? You have the same thing? Yes, no? Yeah? Okay. Number 6, who wants to volunteer? Ottman.
So, y equals 2 sine 1/2. Alright, wait. Oh. And then, parentheses x minus pi.
Oh yeah, parentheses x minus pi, gotcha. Like that?
Yeah.
Okay. I think you're right. I'm going to just go through them so we can point out where you got things from. So amplitude of 2 is here. Phase shift of pi is right here. And if the period is 4 pi, you get your b value by doing 2 pi over 4 pi, which is 1/2. Okay, any questions for Ottman? All right, good work today, guys. Get started on the homework problems, please.